So now we are going to discuss the next subtopic, which is binomial expansion. But before that, should we look into the learning outcomes first? So first we have to find the expansion of a plus b to power of n, where n is a positive integer, as well as you have to know also what is n factorial notations and NCR as a binomial coefficient. And then we should also learn about how to determine the general term in a binomial expansion where n is a positive integer, as well as at the end we should also know to determine the expansion 1 plus x to the power of n, where its validity is for modulus x less than 1 only, where n is a rational number. Before we go deeper into the subject, let's look into this one, how to expand a plus b to the power of n. Okay, so let's say if you have a plus b to the power of 2, okay, so straight away, quick expansion, you would have a square, and then in the middle should be a times b times 2, that would be 2ab, and consequently b squared at the end of it. Alright, that one is for the power of 2. What will happen if you have cube? So a plus b cube, or to the power of 3, that should be quite tricky, which means you have to expand a square plus 2ab plus b square. Okay, slowly, we're doing this slowly. A plus b, some more there. So we should have a cube plus with a square b plus with 2a squared b, as well as plus with 2ab square, as well as plus ab square, and then we would have plus b cube. Okay, so summarize this one, I would have a cube, I would accumulate everything with the same unknown in it. For example, this one a square b, and then this one got a square b also, right? So that should be 3a square b plus with 3ab square as well, and plus with b cube. Alright, so here please note that in fact the power of a is actually decreasing. If you notice, this one got 1, right? And this one is a to the power of 0. That's why we didn't write a at all there. And then the power of b is increasing as well. Okay, and then the coefficient for a squared b as well as ab square in the middle here would be the greatest power of our original expansion. Okay, so what can we conclude from here? That is where the Pascal's triangle came from. The idea of Pascal's triangle came from. So for example, if you have a plus b to the power of 6, okay, so we need 6 stages of the triangle. Okay, let's look into here. So let's say if you have 1, so the edge of it will be still 1, so we have to the power of 6, right? So we need 6 stages of the triangle or pyramid. So it's first one, second, and then here in the middle will be the summation of these two, so that's why it's becoming 2. Okay, follow through 1 at the edge of that. Okay, the same goes with that, the summation will be 3. The summation here also would be 3, and then the same goes with this, follow up with 1, 1, this one got 4, 6, the summation, the summation is 3 will be 6. This one also got 4, this one follows by 1, 1. Okay, so this one got 5, 10, as well as again 10, 5, and 1. At the edge of it will be 1 also. So count your steps. How many steps that we have now? We have to power of 0, starting with a 0. 1, 2, 3, 4, 5. So we need another steps over here for the power of 6. So therefore we need another layer over there. So 1 is always at the edge. This one should be 6. This one got 15, 20, as well as 15, 6, and 1 at the edge. Alright, so meaning that for this one would determine the coefficient for each of the terms in the expansion. So let's look later on, but this one is the coefficients. So let's say if you want to find a plus b to power of 6, so you know that from here that your a would have a to power of 6, but with coefficient of 1 in front, so 1 don't have to write them, and then plus with 6a to power of 5, but b gaining 1 now. 15 is the coefficient, a now is to power of 4, but b gaining 2, the power of 2, and then 20 again as the coefficient, so a cube, b also cube. Alright, and then 15 is the coefficient, but we have a square, b to the power of 4, plus with 6a becoming power of 1 now, b to the power of 5, and at the end of it will be b to the power of 6. Okay, so this is the expansion by using Pascal's triangle. But then this one is valid for n positive only, since we have 6 here, and we're not encourage you to do this because it's quite long. So we have the idea of generating the formula, which for the n is positive integer. Okay, so the formula is just like the one that we have here, which is a plus b to the power of n. We should have n0 of a to the power of n, b to the power of 0, plus n1, a to the power of n minus 1, b to the power of 1, and then so on. Okay, so please note that there should be our tr plus 1, because we do understand that this should be our first term, plus with our second term, plus with our third term, and so on. And note that once you have t1 here, but then your r here is having minus 1 over here, right? So that should be tr plus 1 here lah. Alright, this one is being called as term in binomial expansion generally. Okay, so now we should also understand about the factorial notation. So factorial notation basically is an r. Beware that this is not a matrices. In fact, that one got its own formula, which is n factorial over with r factorial in the bracket n minus r and then factorial. Or instead, you could actually use your calculator. It should be NCR inside your calculator, right? So for example, if you have 83, in terms of formula, should be 8 factorial over with 3 factorial times by 5 factorial. Okay, since factorial means also 8 times 8 factorials would mean 8 times 7 times 6 times 5 times 4 and times 3 times 2 times 1 and so on. But then we want to stop at 5 factorial because we can actually cross this out. Okay, and 3 factorial also can be computed by using the calculator. So straight away we have that. Can also be found by calculator by NCR straight away. Okay, so your task is, please try showing n r equals to n and minus r by playing with the formula.